GATE 2024 question 52. Consider the ordinary differential equation of this form with the boundary conditions are also given. We have to find out the solution at x is equal to 3 over 2. So this is general form of Euler-Cauchy method. This is the typical general form, and the way we solve it, we assume y is equal to x raised to the power m, so we can find out the first derivative and the second derivative and put these right here, and then take x raised to the power m as common. So from there, from the auxiliary equation, we can get the roots. Depending upon the value of the roots, typically we get here, if the roots are real and distinct, so these are all taken from Cauchy. And the details are given right here. If the roots are distinct, so this is the solution we get. If the roots are repeated roots, we get this equation, and if it's a complex conjugate roots, we get this equation. Something similar, but not exactly the same for other second order differential equations. Let's quickly see what is the practical application of these equations, typical applications in heat transfer. This is a very standard one. When we have steady state heat conduction in spheres or cylinders, we typically get this kind of equation, especially spheres, even in cylinders also. And which on expansion we get this. So this is again a form of Euler-Cauchy equation. You can see BSL, Bird, Stewart, Lightfoot. In reaction engineering also, for reaction spherical catalyst particle, we get this kind of equation. These are of course dimensionless concentration and the distance or the radius variable. You can look at Levenspiel for this one. Even in process control, we get this typical Euler-Cauchy equation. So that is a very good practical application of this equation. Anyway, from this equation we get, once we substitute, we get these are the roots, and again these are distinct roots. So from here, this is the general solution we get. Once we apply the boundary condition 1 and 2, we get this particular value 4.041. So this is my answer, and the details of course are given here.